Ooga booga. Ooga booga. Yeah. Hello. Hello again. After what? How many months? A month? I was lost. Here I am. Back again. Ooga booga. Hello and welcome to my very first coding stream. So because of unforeseen circumstances, I suddenly have merged code. Yes. Now, it's very fascinating now. How coding is very good. Like, so good. Like, bruh. Well, today I'm going to play COMET 64. COMET 64 is an indie game, so I highly suggest you to support the developers behind this game. It's very good. Very good game. For those who want to learn programming and do some puzzles, then COMET 64 is here for you. Now, I don't know if you're familiar with the games Shenzhen.io or TIS 100, where the TIS 100 focuses on more on assembly language, like real computer code, and the TIS 100 is the real computer code, and Shenzhen.io is more on the inputs and outputs of electronics, I guess, if I remember correctly. Now, I am planning to stream those two at a later point, but right now, let's dive in on COMET 64. Hey, the year is 1964, and it is where Hackerman lives during this time. Right? Let's go. Wow. This is nice. This is a good interface. Okay. So let's create a new game, shall we? I'm going to name it as Legit, because that's my name. I'm Legit. Whoa! This is actually cool. Yo! We got the user, the Legit PC, and Voodoo 4. That don't work. Ooga booga, hello Tinka. This. Oh yeah, the computer is slow in this. So we have different types of disk, and we have disk A and disk B. That's interesting. Going to adjust the volume. Okay, so I think we're going scan lines here because to make it look authentic. Now I don't know which interface is better. That reminds me of the early days of hacking. My eyes, Commodore DOS. I'm going with Kada because it's blue. I mean, business is blue, but it's too blue for my taste. Einstein, hello, ooga booga. Yeah. Of course, we're gonna pump out the FPS gaming. And yeah, that's basically it. Okay, I'm going to settings. Okay, COMET 64 documentation for the COMET 64 home computer. Hello. Okay, first things first. Relax. Okay, that's crazy enough. All this talking to computers business might seem crazy or daunting at first. Okay. Oh, there's a PDF file. Nice. So this is the interface. The toggle ports, register panel, input output. Mm-hmm. So they have stop, pause. It's pretty generic stuff here. Oh, hello, Tiaro. Hello. Buhuga, buhuga. So we could execute lines on the current line. Okay. Read only, write only. Syntax. Okay, 5 types of register. We have reg or the float, decimal, int, integer, bool, boolean, string, character, all that same stuff. Okay. I know a little bit of coding. While writing a decimal value to int, we'll drop its decimal part. Yeah, because integer only focuses on the numbers, the whole numbers, not the decimal parts. And then syntax, of course. Operan. Ports and constants. Also, you could name your constant numbers. That's quite interesting. Now, in modern day programming, they won't allow this because they would treat it as an integer or float. But okay, this computer needs a little bit of work on programming language design, but pretty good. Must end with a semicolon. It's kind of a C++ thingy, or Java, or C in general. Time for code. Writing to registers. Oh! Okay, sets reg. Read and write. Read only. Reg in. But reg is a float value. Reg int. Switch can store a value from any register, but it cannot be directly written or read. Instead, it switches the value of a register with the value that's stored in switch. So this is like an extra pointer. This is how pointers work. Thing plus part. Because if I remember correctly, int, that's reg equal to int. Logic, we have label start and negative begin here. Okay. Start and negative begin here. Oh, so this is like functions. This is how functions naming, I see. Jump statement, it's like the go-to statement for but the programming gods won't accept that. Now checks is just a bool statement if string is gone. I see. Check input equals to null. Does not remove inputs. Okay. Hello, Elise. Hello. Okay. So far, so good. The logic's quite simple. You got the extras here. Int converts a letter to number. Oh, this is quite interesting. Oh, this is actually good. You have the length here. You determine the number of letters of a string. Oh, so this functions. This functions as Python. This is how Python works. +1 letter. Oh, so you could int plus like plus. So this is a post-hand addition. I mean, it would be nice if they would add ++ int Return, reset the previous jump instruction, comment. Okay. 1, 2, 4, 8, 13. Okay. Let's get to coding. I mean, sounds easy enough. So, okay, what's my ins and outs? What's wrong with this code? Read the values from input and write them to output after a discount of 20%. Right. Let's remove this line of code here. Okay. After a discount of 20%. Yeah, I forgot. Man, I keep forgetting. How do I do this? 0.10. So if 20%, you need to, I think, multiply the number by 0.2%. Am I retarded? Could be wrong. Okay, 20% of the value. So we need to multiply it by 0. Now reg is a float, so I could easily do it by saying multiply by 0.20. And the output would be reg. So you have this thing after multiplying it by the reg and minus reg. Oh, I'm typing in Python. Semicolons, yes. Oh, it passed. Okay. Oh, so I could optimize it. Okay, I see, I get it. So what if I copy this? So make it one line of code because I am a pro coder. So if you get the input here, I don't know if they would apply the parentheses here. We know that the int is an input. I mean, we could always go for output here. Then remove this line of code. Then reg is int times int 0.20, so we could remove this thing again. So we do this. See from int times 0.20. I mean, would this work? So it won't work. So let's try if we could do chaining arithmetics and then post in a reg. Unrecognized syntax. Oh, what? Okay. Mm-hmm. I see. I get your point here. Oh, did this? Can't. But I go for input instead. Bruh. I broke the code. Yeah, how's input though? I go into the settings and I'll keep register panel open. I could see stuff here. So if I put input here instead, I'll remove the extra space here and then what again? With registers too. It's -2. Okay. Input 0.20. Man, you'll really recognize how a computer science does things because they would optimize it really hard. Like, bro. Some of my hacker friends are much more better than me. Like, oh my god. If I could hack time, I think they could hack the entire universe, I guess. Hackerman is so strong. And also his colleagues. Bruh. Okay, so you recognize it. Input. Oh, I see. So it converted it to int. You could do it in 2 lines of code? How? How do you even do it? I mean, is there a way? Like, bro. How do they even optimize this thing? Because you can't, if I remember correctly, you can't chain inputs. There's only one arithmetic operations every time. Oh well. Remove their negativity. Well, in mathematics, you could always multiply it by 1. So I could go for int is equals to input. Then register. Sets int equal to input. Okay, so if I write stuff here, let's say a random variable name and I put input, what would happen? I see. So you could, it's either string or ints. How about input times 1? Then you go for output int, I guess. Okay. Speed. Use 30 or fewer steps. Use 2 or fewer lines. Man. My code is optimized. Oh my god. I mean, good. 2 lines of code. That's so easy. Yosh. Yugi. Read the weight, followed by height, values from input, and calculate the BMI. Formula is weight divided by height squared. Now, how do you height squared? Do we do it the hardware, like multiply it 2 times? Could be. Okay. Okay. Read the weight followed by height. So I'm assuming weight could be kilograms and height could be also like not kilograms. Weight could be a double, or height can also be a double. So I could go for double inputs. Wait a minute. How do you have multiple stuff? Then, okay, you can... Okay. In the upper right corner, you can see the switch box. Switch can store a value from any register but cannot be directly written or read. Instead, it switches the value of a register with the value that's stored in switch. I mean, is it possible to do multiple inputs? Reg is also input as well. That's maybe input 1 and input 2. 86. Okay, so first numbers would always be odd numbers would always be a integer. So 1, 3, 5, 7, 9. So we could first input would be an integer, and our second input could possibly a register. It's good. Then what we'll do here is calculate the int again. And I mean, I don't know if you could do the int times. Yeah, you could only do int plus plus, so you'll be wrong syntax here. So int, and then that would give us. No, wait, that's the weight. So read the weight followed by height. So height, weight first is integer, height is reg. So you do for reg, then reg times reg. That's good. Reg times reg, and then output it with int divided by reg. Let's see how it goes. Yabe. Oh yeah, I forgot about that. Reg is int divided by reg now because it stores on this thing. And then you output reg. Man, this is quite complicated. Huh. Coders back then had it hard because there's no variable namings here, but using registers on a certain memories here. This is quite interesting. Quite interesting indeed. Hello. Hello, Michu. Oh, I'm just coding here. Brainded coder. You should output it this way. If I run. Wow. Wait, you can do this in 3 lines of code? Wait, is it even possible? Bro, what? Ignore the input for now and output all the numbers from 1 to 100. Okay, so you could go for 4 loops here, but as we've known, there's no loops but jump to. So this is a for loop. Bruh. If only I could. User manual loop. Jump 2. So if jump if true. How do you even output it? Jump if false. Does the loop end? Jump loop? Okay, so this would loop itself. So do we have an infinite loop here? That's good. Now since we have int 1 and then int plus plus and then output. Wait. Yeah, output first the int and int. Now how does checking does? Sets bool true or false. Check int is equals to 100. Going to check int is equals to 100. So it is. Oh my god, I am so bad at coding. Because it would lead to infinite loop. So if I set this again. 2, 3, 4, 5, 6, 7. Okay, I think it should be good. Yeah, let's test it. Speed it up. Okay. What? You could use 2 lines? How optimized is this code? What? 2 lines. Wow. Okay, how do I... This is quite interesting. positive for 0 and then in plus plus. End of the line. It outputted in plus plus instead. What? Is it because it's slow? Wait, so if I'm going to loop this 100 times, 1, 2, 3, how does looping work? Looping. And what would happen if I do this instead? Hello, my friend. Hello, Ghost. Can you put check with loop? The if statements is kind of limited here because you could only check jump if false. So it checks if this thing here is true or false. So you're gonna put something here. So the only thing to know if to test if statements is checks instead. Yeah, so you can't put checks here because those are labels. Or if I say look here, you can't put any checks here. I mean, the answer is already given, but I want to optimize it. Oh well, I could return this later. I would waste my time here doing stuff. Okay, what goes up must come down. Okay, I'll put the countdown to 100 to 0. So I think we put some labels here, which is going for loop, and then an integer starting with 1. I don't even know how they optimize this thing. For 100 here. Output is equals to n. Oh, check if. Oh, check the end if that is less than. Okay. Check if our integer is less than 0. Jump if false. Ooh. Is it possible to int minus minus? Oh, this is the countdown. Yeah, it's a new programming language called Comet 64, and I do not understand its syntax because you could only do one operations per line. Like you can't do multiple checks. There's no while through here. But this is kind of hard. Nevertheless, I think I could do it. Oh, so you can hit minus minus. 0. In minus minus. Five lines. 404 cycles. I'm going to die here. What? How are... Why is their solution so fast? There's even 300 cycles only. In 3 lines of code. How... I don't even know. That's so... bro, what? Is it possible? I do something there. Jump if to start. Tell me they made this instead. I mean, this could end with... the heck? So it doesn't matter if your program goes... There's no ending point here. Like, what? It would go on minusing. Bro, what? Okay. Okay. Still though. 3 lines of code. Those are demons. For each value from input, output, the greater one. Ah, so you want to do comparison checks. Okay, so comparison checking on 2 inputs. Go for it. Right. Wow. Num1. Num2. Up to 10. Readability, and then so check int is greater than rec. Okay. Jump if true. Jump if true, it would go to num1. Jump if false, it will go to num2. Since we are pro coders, we're going to remove extra lines here. Okay, so we have, wait, what? What? I thought... What? How do you even stop here? Ah, return. Okay. Got to put my return functions. Okay. Return. Okay. Three. I'm wrong, so I could put return here instead. Return, return. Then if false, they would go ahead and return. Ah, I'm going full on object-oriented programming. I'm going functional programming. God. Oh, I mean, they're killing me. I don't even know how return functions work. There. Should be happy. Lines versus 7 lines. I mean, you could go for jump if true. Yeah, that's nice. Okay, anyways. Next code. Okay. Input contains a list of dates, but some dates are written twice in a row. Whoa. Whoa ho ho. Whoa. How do you know? Whoa. What? Can you do this instead? How do you know if there's a duplicate? It would be nice if you have arrays, but wow. Ah, I can just copy this instead. Twice in a row, so if I know that these are equal, We jump if through dupes. Name it dupes instead. Okay. Int and register. Input. If both of them are equal, dupes then tend to output the main. Return. What? (1956). There was 1993. 1965. There's 1965. Oh, there's something wrong. Hey, first input 1956 and 1993. If this is false, it would return. What again? I am bamboozled. Okay. So 1956 it would input. Then check. After that, check if it's true. Then 1993, 1956. So it would switch to return. 1981, 1965. Check. True. Check. Oh, it's on every odd number. Okay, this is quite a doozy. Okay, 1956. You input and then input. You check if it's true. Since it's false, I return. (1981) and 1965. You check. I do this step. Okay. Oh my god, this is hard. What you want? What? How? What? Ah, my brain. I mean, there should be something that would keep track. I don't know how switches work. Let me do some little experimenting. Okay, I think we could use switches now. So int input. Then you switch the int? Ah, I'm wrong. It first inputs. And then you switch the reg, and then you switch the int. It's just you're just switching int. Okay. How do I do this? How do I do this? So you need to input 1. Input 1 first. After inputting 1, then next number will be 2. I need to know if 1 is greater than 2. Check 2. Right after that, okay. What if I check if the red is equal and just like this. Well, I switch the int and then check if int. Am I doing it right? I think my logic is wrong. Oh, interesting. So it does work. Okay, okay. So we just are going to name this do. Then I should output the register. What? What is this debug? Turn. Huh? Maybe there's 2 functions. So it would output it one line by line. Or should I put some main here instead? Then just go jump to main. And Well, my solution worked. It is by using switch as my temporary variable and then getting that temporary variable to do the checking. It's null. Okay. It works. It works, but it could use a lot of work. Oh well. 0 marks output the sum of every package. Wow. How do I even do this? Whoa. Okay, my brain is dead. My brain is dead. Okay. So I'll solve this last problem. Okay. And as I'll end this stream quite early, because I don't want to bore you guys with the intricacies of coding. Okay, so how do we do this? 4260. So hacking is really hard. So let's put it this way. Usual, get our inputs. I think it's better to have a helper here, right? Main here, then input, then registry reg. Okay. So 1, 1. It's better. 1, 7, 9. I think we could reset this so back end is equals to 0. Jump if to reset, because this would reset our registry here. So we're going to reg is equals to 0, then return. Oh wait. Jump if true, then go for reset. Return to main. Or jump to main. I think this should work. I'm going to invert my function here, int, and then plus, right. Okay, so what we're doing here, we're going to check if our input is 0, yeah. And then it would jump false if it's false, and then it would do its main thing and then jump to main. If it detects 0, it would reset the registry and do the return. Turn again. Okay, I'll go to jump to main. That's even better. Add. That's a better name. It would output the reg, then it would reset to 0. Yeah. What? How is this not fast enough? Like, bro. How is this not fast enough? In 38 cycles. I don't even know how return works. Woohoo! Oh my goodness gracious. Well, that was a good fun in coding. That make your brain go booga booga. Code 1. In any case, wow, that's so far our coding experience is kind of good. Just so you're wondering, this kind of applies in the real world, yeah, where coding is king. Very happy to code. For the problems are quite easy enough. It's kind of frustrating that there would be someone that is better than me. Look, 9 lines versus 10. I'm missing about 1 line. And cycles, 8 cycles. So I don't even know how to optimize this. Is it because of the jumping? Yeah, we ain't gonna cut it. But there is 70 cycles. Like, how optimized are those codes? Bro, what? Yeah, well, in any case, I thank you all for joining in my dwindling sanity of coding. Yes, this is the world of programming. It's full of very specific stuff. Yes, my brain is now brain dead. Yes, this is what makes coding fun. There are solutions that are very quite interesting. Spring, winter. In any case, I think I'll end this stream now. I'll keep on doing coding streams for once in a while here on YouTube. Yes, because I want you to learn the beauty of coding. And if it gets down to it, I could teach you one of the ways of the hacker men. We're gonna hack something. I know, no wonder what could it be. Well, in any case, please stay tuned for more coding streams like this if you want to see my dwindling sanity. Like, even I can't understand how they can optimize this thing. What? Whoa. Well, in any case, I thank you all for watching. This is Leibniz, and yeah. Ooga. Booga.